Good morning, good afternoon, and good evening. My name is Natasha Merat, and I'm a professor of human factors and transport systems at the University of Leeds. Welcome to this session, this breakout session on human factors of teleoperation. I'm very happy to be joined by colleagues around the world who have agreed to provide their understanding and perspectives on this topic. And I want to also thank my co-organizer, Emma Johansson from Volvo, who's been working with me. We are both involved in the Arcade project, which is funded by the European Commission. And we've been working for the last few years on networking aspects of human factors of automated vehicles. For today's topic, we have chosen something which is not my own expertise, on teleoperation, and you may be involved in teleoperation or interested in teleoperation from your work, but we think that when it comes to the human factor side of tele and remote operation, we're still at the very beginning. Some companies are working on it, but from a human factors perspective, we feel there is still some understanding, some standardization, some frameworks, etc., some work to be done in this area. So the breakout session will include small, short talks by 4 presenters, and then we have about half an hour at the end where we will respond to your questions and answers, and also have a bit of a panel discussion between the 4 presenters, including myself. So before we start, we have this fantastic setup that we've been all involved in. If you've been involved in the EUCAD meetings up till today, the Slido, where we will be asking you to respond to 4 questions, just to get a feeling for who you are, where you're from, what you think of tele and remote operation. So if you can please use the Slido to respond to the 4 questions, which will take a few minutes, and then we will present that before we go on. So there's, as I say, there's 4 questions, so quickly trying to respond to those, and then we'll get an idea of where everybody is from and so on. So if you have not used Slido, as this is the first breakout session you've been involved in, it should be quite easy to just press on the Slido button on the right of your screen and respond to the questions. So, and of course, we are breakout 7. So we've got 3 responses so far. I'm not quite sure at the moment how many people are live, so we'll wait a minute or so before we see the responses to those questions. Okay, perhaps we can have the survey presented, and I think that you can continue to respond to the questions as the survey is being presented and we see the results of that. Right, thank you. So we've got about 34 people responded so far, and by far the majority of you are from Europe. Some are being more specific about which country. I wonder if the UK is there as UK or Europe. Of course, it's interesting one to see, but even looking down at the various countries, we have one from Japan, but again, mostly European countries. I can't see anyone. Oh, there's a Canadian one. I don't know if that's Joanne or colleagues from Joanne. Okay, can we go to the response to the next question, please? Right, okay, so most of you are from the research side, some from public administration, industry, etc. But again, the majority of the 40-odd people are on the research side. Nice to see. Okay, and the next one, please. Okay, so in terms of remote operation, teleoperation, whether it's in automated vehicles or automated systems or manual control. Most of you have not had any experience, but it's nice to see that around 30% of you do have some experience, and I'd love to hear from you when we've got questions and discussions, what your thoughts are on the presentations. And then finally, response to the last question, please. Okay, so how do you feel about operation of the automated system? Can they accelerate the deployment of automated vehicles, teleoperation? Yes, but the majority of you say yes, and I wonder how many of those are the 27% who are working on it. So you feel quite positive, which is nice to see, and we'll see how your response change when we go to the presentations. So on that, let's go to our first presentation. I'm very excited and honored to have Azra Habibovic from RISE in Sweden providing some details. She's been actually amongst us one of the ones who's the most experienced on trying to understand the human factors of teleoperation. So Azra, over to you, please do start.
Thank you very much. And I don't know if I'm supposed to see my presentation, but I don't. So this will be in Blinder. So sorry for that. Just a few words about RISE. We are independent non-profit research organization owned by Swedish government. We do research in various areas, and one of them is sustainable transport, where I work. And myself particularly, I focus on how people interact with new technologies. And today I will talk about the role of human remote operator when it comes to automated vehicles. So remote or teleoperation is a process in which a system or machine is operated at a distance, mainly by a human operator. But what is the role of this human remote operator in the context of automated vehicles? Well, according to SAE standard on automated driving systems, you know, the one with automation levels, a remote operator is a driver who is not seated in a position to manually exercise in-vehicle braking, accelerating, steering, and transmission gear selection, but is able to operate the vehicle. So next slide, please. To figure out this, let's have a look on how different stakeholders use or anticipate to use remote operation. Next slide, please. So Argo AI, a startup, want to use remote guidance, as they call it, in a select group of particularly challenging conditions when the self-driving system is unable to make a requisite decision or requires additional guidance to do so. They emphasize that remote guidance does not provide teleoperation to remotely drive the vehicle, so no driving, according to Argo AI. Next. While Cruise and Yandex are aligned with... Next slide, please. Thank you. While Cruise and Yandex are aligned with Argo AI's vision, Neuro, for instance, has a bit different plans. They say that they will use a remote operator as a backup, able to take control of the vehicles and navigate them to a safe position. Next slide. Waymo, on the other hand, has a very recently declared how they use remote operators or fleet response specialists, as they call them. When the autonomous driving system, what they call Waymo Driver, for instance, faces some road obstacles that the driver is not able to handle, this Waymo Driver then contacts fleet response specialists to provide advice on what route might be better. However, Waymo emphasizes that the final decision is always with Waymo Driver. So no driving here, according to Waymo. If we then look at the vision from Android, for instance, they envision that one remote operator can take responsibility for several self-driving pods, monitor them when in autonomous mode, and then take active control of vehicles for unforeseen or complicated maneuvers, such as parking at a loading dock. Next. So in sum, remote operators are anticipated to monitor or assess operation of automated vehicles. They are also expected to provide assistance or guidance to vehicles in very tricky situations, or even to actively control or drive vehicles in extremely tricky situations. Put another way, remote operation may be applied at strategic, tactical, and operational level. So cool, right? Next slide, please. But are we really cool and confident with putting all these expectations on a human that we originally removed from the vehicle because of risk for human error? Next. My answer to this question is very well reflected in the following quote from 1983, where it says, "One is not by automating necessarily removing the difficulties, and resolving them will require even greater technological ingenuity than does classic automation." Next. This is also reflected in our recent work, where we, through literature review and expert workshops, concluded that there are still many challenges and research gaps when it comes to human factors in remote operation. We have identified 21 research gaps or questions that need further attention. I don't have time to go through all of them, so instead I will present 2 gaps that we are currently further exploring. We found these 2 important both from human factors perspective and from business perspective of autonomous vehicles. Next slide, please. These 2 topics that we are currently looking into are how should the remote operations center be designed to allow the operator to swap between different remote operating roles? And how should this remote operations center be designed to allow the remote operator to operate multiple vehicles? Next slide, please. As a first step in addressing these gaps, we are looking into roles of remote operator in 2 similar but different applications: heavy automated vehicles that you can see on the left-hand side, and small automated delivery pods on the right-hand side. So far, our work has mainly been focused on heavy vehicle application, the one on left side, where we have identified a bunch of different roles for remote operators. Next slide. The most frequent role for remote operator will be to assess and monitor a vehicle and handle various error messages. Probably one remote operator will be able to monitor many vehicles simultaneously. But as you know, monitoring is rather boring, and there is risk for operator to get distracted or mentally disconnected from the task. When it comes to providing assistance and guidance, we believe it's likely that at least a few vehicles could be assessed simultaneously. But this is a role that requires extensive understanding of local rules, norms, and practices. So it requires very good understanding of automated driving system and its capabilities and limitations. This since the operator and system need to collaborate and resolve together situations which are tricky, and also to do that within a limited time frame. And then we have also a remote operator role where this operator will drive vehicles in very tricky but rare situation. In this role, it's natural to expect that the operator will be able to operate only one vehicle at a time. And this is probably the most challenging role, since the operator will need to quickly understand the context and jump in to drive the vehicle and make right decisions when driving the vehicle. So one challenge here is, since these events will be rare and rather unique, it might be difficult for operators to get enough practice. Next slide. So it's also likely that the operators will need to swap between these different roles. And swapping roles comes with its own challenges that put some important requirements on the design of a remote operations center. For example, for each role swap, the interface needs to be designed in a way that enables the remote operator to quickly shift focus and orientate in the new context, as well as to easily figure out what are the appropriate actions. So we believe that this will affect how many vehicles can be operated by one human operator simultaneously, which is also, at the end of the day, something that will determine whether automated vehicles are feasible from productivity perspective. So having said that, I would like to invite you to visit our virtual exhibition where you can learn a bit more about this topic and what we are doing. Thank you very much.
Thank you very much, Azra. I should have said that we're allowing one question at the end of each speaker's talk. So if you have any questions, please go ahead and type them in the question and answer. If not, we will move on to the next speaker and we'll have more questions at the end. So I don't see any questions at the moment. So in which case, if it's okay with you, Azra, we'll move on. I have got a couple of questions myself, but I'll keep them to the end if that's okay.
Yeah, sure. Go ahead, please.
Okay, great. Thank you very much for your talk. So next in the speakers is Joanne Harbluk, who is from Transport Canada and has been working on a paper for the UNECE as part of the HF-IRADS working group, and she'll tell you a little bit more about that in a minute. Joanne, please go ahead.
Thanks very much, Natasha. Yeah, I'll just mention that I work, the group I work with at Transport Canada is Human Factors and Crash Avoidance. And what we do is we focus on the human factors part, also within our group looking at crash avoidance. And so we've been looking at research from the perspective of human interaction with automated vehicles, both inside and outside the vehicle. Okay, so thank you for that introduction. That's great. If we could go to the next slide, please. Oops. Okay. There we go.
No baby.
There we go. Okay. I just wanted to take a step back and look at some of the questions and the considerations about why we would ever want to use remote support and control. And it's helpful to think about why they use them in other domains, for example. So in harsh or extreme environments where it would be dangerous to have a human operator, it definitely makes sense. If you think of underwater working or other extreme environments, where it would be unsafe for a human to be there for a long duration or to actually be there at all. Also, it's very useful to use a remote type setup when you can improve the working conditions for the person in control. So we can see design where new interfaces are devised at a remote location that make the on-site work a lot easier. And so there could reduce workload and fatigue. So these two examples and some of the other ones that we'll hear about are really focused on safety, obviously, but there are also some economic arguments in there as well. The last bullet on this slide is a situation where remote support and control gets suggested as a solution, and we've been hearing this lately, and that is when an automated driving system requires assistance or control to actually negotiate a difficult or unexpected situation. So something's happened, it can't resolve it on its own, and the idea is to get the assistance from a remote operator in a remote location. And there's also situations where a driver or a passenger needs assistance, and that would be useful as well. Excuse me. So as I mentioned, we do hear about these options. and they do get mentioned, but often they're mentioned without a lot of specific details or really a lot of context about what's involved. So if we could go to the next slide, please. Oh, sorry, the one before that. Thank you. So Natasha mentioned a paper that a number of us have been working on, and the paper itself was developed in the fall of 2020, so last fall, and it's to focus attention on these issues of remote support and control. And the group that produced it is called, it's long, but I'll read it out, Human Factors in International Regulations for Automated Driving Systems, or we call it HF-IRADS because that's a little easier. And this group brings together human factors experts, and they're from around the world, which is really great. And the intention is to support UNECE activities on the safety of automated driving systems. And I mentioned that the motivation behind this was to actually really address some of the human factors issues that are being discussed, but to look at them from a more specific perspective for human factors needs. We could go to the next slide, please. Okay, this table is just kind of where we started to look at remote assistance and remote management. And one of the things, a couple of things here to actually mention, the table's set up to look at really the roles of what the remote operator would be doing. And so there's essentially three groupings of tasks, and they're similar to ones that are used in other documents as well, certainly Azra's presentation as well. But the basic idea is that there are situations of remote assistance where the information may just be what's required, and that's a relatively simple thing to do. There could also be situations of onboard monitoring where it's desired to have visual and auditory monitoring, for example, of the system for passenger information and safety, just to see what's going on. A second type of remote support or control has to do with management, and this is more involved with knowing what's going on around the vehicle and trying to assess what's going on and be able to guide the vehicle in certain ways. So there could be authority here to resume movement, that type of thing. And the person involved here might be a remote dispatcher, or it could be a relatively simple situation of a hazard in a roadway, and they could help in that way. The third category is more involved, and this would involve temporary or full control under normal, unexpected, or emergency situations. I'm starting to hear feedback and I'm not sure why, sorry. There may be remote driving at low speed or high speed, for example, and it could be dealing with failure modes. And so it's more extreme situations that are more time sensitive and require more skill. Although there are a variety of aspects in this table, it's important to think about when this would be appropriate and when it might not be appropriate. And so it's the situation, for example, at high speed and particularly traffic, busy areas may not be something that would be safe to take it, to actually undertake. Okay, could you go to the next slide, please? Great. Okay, in this slide, it's just 6 sort of items that were included in the paper, and there are areas where there are known human factors considerations that are either from other domains or from current research as well. Now, the paper provides some examples. Obviously, it doesn't go into a lot of detail, but the work that was done for this outlined these areas of concern, and obviously there'll be others as we learn more about what goes on in these sorts of environments and working conditions. To just say a bit about the remote working environment, I think Azra made some really good points about what it could be like and the complete differences there would be from some of the ways that control of vehicles goes on at this point. So again, it may depend on the type of assistance that's being provided. It could be just one person on a call line being able to respond to a variety of inquiries. But as things get more complicated, there would most likely be a dedicated person on a one-to-one sort of relationship with the vehicle. And it's important here to consider what goes on. It's not just the number of systems that they have to monitor, but there's also an important component of having to do with the amount of time where you don't have to monitor something. And so that comes into play as well. The second item is looking at personnel and training. And this is, again, quite an interesting area. You can imagine just simply driving a vehicle on its own requires a certain skill set, but to be able to do that in an effective way at a distance is, again, quite demanding. And so there would be certain types of training, those sorts of things that would go on. And also what's important is for those people who are involved, we need to think about what it's like for them. How are they able to maintain, say, appropriate attention for monitoring and appropriate situation awareness? How does decision-making get made in those situations? When do they know they have enough information to make decisions? So there's a lot at play there. In terms of controls and displays, of course, those are also important. They could be quite simple. They could be very complex. And again, how do we display things in the most appropriate way for them to be effective? They could be very different from simple screens, and it'll be interesting to see the sorts of new ways in which people make that possible. The communication channels, of course, are important. We need reliable technology and infrastructure, and it brings up the issues of delays, which I know are an important concern. In terms of passenger needs and requirements, this is also an important consideration. If a vehicle is being remotely operated, what is the communication like with those passengers? How do we deal with any needs that they have that come up? And say if there's an emergency on board or with trip interruptions, those types of things. And the final point on this slide has to do with service design and operational design domain. Where are these vehicles being operated? And I think that's an important consideration because that sets some bounds around what's going on. So the point really of the paper was just to lay out some ideas to make people think about things, hopefully to generate some research needs for people to go forward with the work. And I should mention that although I'm presenting on the paper today, it represents the input and hard work of many people. And it's great to have everyone contributing. Okay, we'll go to the next slide, please. Okay, I wanted to just put this slide up and talk just for a moment about passenger needs and think about what has to actually happen in a system to provide some sort of effective assistance for a passenger. This schematic is from the Automated Vehicle Safety Consortium, essentially SAE. And if you move sort of from left to right in the diagram, this particular system is for passenger-initiated emergency stops. So it starts with the passenger determining that there's a need for an emergency stop in the vehicle, and they're able to actually request that. And so this sets the system going, and it goes in two directions. One to the vehicle itself, which controls the vehicle on the spot, and the other is to send it to fleet management operations. And this is sort of what we think about in terms of the remote operation. And if you think of sort of the three players in this particular figure of the passenger, the automated vehicle system, and the remote operation, you can see that there's an important interplay, even in the case of something like a passenger-initiated stop. So the vehicle itself can make itself stop and perhaps set some sort of warning that it has been stopped. But a lot of the activity happens in the lower right of this schematic in terms of fleet operations. Only they can really determine and know about what their particular issue is and how it might be appropriately dealt with. And so although there's very few boxes in that lower right corner, there's an awful lot of work that would go on there. And that would be the responsibility and the role of a remote operator, perhaps a team of some sort that could take care of that. Okay, we'll go to the next slide. Okay. Okay, and this is my last slide. Basically, I just wanted to sum up, and I think it's safe to say that remote control and operation is complex. We're dealing with humans in various locations, for example, also with automated driving systems, and all the complexities around remote operation. And we really need some sort of framework to be able to really look at these and understand these complex situations. And so use cases really need to be investigated and understood. There's so many different possibilities, and often we hear people just talk about remote operation as a solution to a problem, and yet there's so many different ways it could be implemented. And there may be possibilities where it doesn't actually provide a solution to the problem, and so that can't be an assumption. We need to know more and understand that it could be done safely. And so that also calls up the importance for safety case for each application. The design of the work environment is really essential, and there's so many different ways to look at the human roles and responsibilities and what's being asked of them, but we also need to remember that it has to be done within the capabilities and limitations of human performance. And Azra discussed a couple of really important points about, what can people be assumed that they can do, what can they actually do to operate and keep something safe. But that design of the work environment certainly can be optimized to help with that. And finally, I wanted to say about the importance of research to support these activities. There's so much to be done. There's design guidance that's very valuable, best practices for safe and effective use. And we need to know, how do we evaluate if something is safe? What's the best way to look at research issues and different assessment procedures? Anyway, that's what I have, and thank you very much. If you go to my next slide. Great. I've left 2 links up there if people want to follow up on the pedestrian stop document and also for the HF-IRADS paper. Thanks very much.
Excellent. Thank you so much, Joanne. Yes, I was going to mention that the paper is available online. Obviously, people can't click on that yet, but the presentations are going to be provided online. So, and if anyone wants to get hold of that quickly, please do get in touch, and we can help with that. So we have got a couple of questions, but I am going to move on to the next 2 talks. But hopefully you've realized actually that both Azra and Joanne's talks are around what are the issues that we need to look into when it comes to human factors of remote operation. So all the research questions, all the challenges that all the research needs. So rather than having hands-on experience yet. However, I'm happy to say that the next 2 speakers have got a bit more of an understanding of what the human factors challenges are as they are observing these remote and tele operations happening in their sort of day-to-day work. So with that, I want to introduce Rosemary Hellqvist from Volvo. She is a UX engineer, and she's going to give us an overview of the work that she's been doing with a bit more hands-on experience. Rosemary, please.
Thanks a lot, Natasha. I will see if we can get my presentation going. Thank you. So I come from Volvo Construction Equipment, and I'm so happy that I could be invited to this forum because, well, I am the cousin from the countryside, I would say, and I work mainly off-road, but try to see it in the on-road perspective. And I think we have a lot to learn from each other. Next slide, please. So my name is Rosemary Hellqvist, and I work at Volvo Construction Equipment in Eskilstuna in Sweden. I'm working as a user experience engineer, and my main focus is remote operation and automation. Next slide, please. Volvo Construction Equipment is one of 11 business areas in Volvo Group. So we are a big company, I would say. with a lot of different areas. Next slide, please. So the Volvo Group business areas includes trucks, buses, construction equipment, power solutions of marine equipment. And the Volvo Group is very focused on develop electrified and autonomous solutions. Next slide, please. And Volvo Construction Equipment strives to be a total solution provider. I would say not only Volvo Construction Equipment, actually, or all Volvo Group. Well, we strive to be a total solutions provider with not just the machines in focus, but also services and the customer experience. And this is very important, I would say, when it comes to automation and remote, because we are not making machines, only machines anymore. We're making solutions. Next slide, please. And within Volvo Group, there are several ongoing projects regarding autonomous solutions, such as autonomous transport and autonomous docking to harbor. We're also working actively with remote operation. There can be several reasons why remote operation is useful, and I think Azra and Joanne, you have both been touching on them a lot. It can be the vehicle ran into technical issues, meaning that it needs to be moved out of the traffic or from the planned track. There can also be situations at crossroads and so on, when it's safer that the machine or vehicle runs remotely instead of automatically. And when it comes to construction equipment, there are many times it's a situation when it's too complicated to be handled automatically, but still beneficial not to have the operator in the machine. One example that we're working on now is timber handling that can take place in several places that are remotely situated, and then you want to have one center for the operator who can run all the machines on the center on the different locations. Another challenging situation is when it's too dangerous for an operator to enter a working area, and that could be in the mining industry, for example. After a blast, typically the company must wait several hours for dangerous gases to clear before an operator can go into the mine. But with a remote operation, no waiting is necessary, and that saves the company time and money. Next slide, please. Oh, I'm not sure if I'm, I think we are in disorder now with the slides. Could you go back, please, 2 slides? One more. Thank you. So a typical setup for a remote platform is divided into following basic areas: the project's aim, different feedback and control solutions, understanding requirements on the communication between the control platform and the machine, and the machine's possibility to simplify the work. And that can be to set up sensors and so on the machine. Next slide, please. But we cannot do this alone. We need the collaboration. It's very important. I would say that I feel very much alone sometimes because I'm the only one of Volvo Construction Equipment really working on this out of a human factor perspective. We have several ongoing projects with customer universities and research institutes, and that is necessary. For me as a user experience engineer, this is crucial when we work with unexplored techniques and for the users of tomorrow. Next slide, please. With construction equipment, remote driving control stations can be set up in various configurations that reflect the needs of working environment. But how do we set up an operation station in the future, and how do we standardize it in the best way? Also, how do we make sure that the operator has a good sense of reality when operating the machine remotely instead of feeling like a video game? Next slide, please. And we also need to understand the machine and the human context together, including understanding that we cannot expect one single solution. And that is one thing that we work very hard with now when we work together with customers. We have to be flexible all the time. Next slide, please. As a user experience engineer, I focus on the human being. And this focus is broken down into areas such as target group, culture, market segments, and so on. Next slide, please. And communication is important, and this is good that we are here now together, I feel, and doing this together. And my question is, how do we communicate in the traffic in the future? And I think to manage this in the best way, we need to speak the same language and make sure that we understand each other. We need to collaborate. Next slide, please. And that was actually all for me from now. I have a lot, but I didn't want to dig into too many details. And you are all welcome to give me questions now or reach out to me in the future. Thanks a lot.
Thank you very much, Rosemary. Yes, so I mean, it's interesting. It feels very much like with many other aspects of the technology being developed, and then the consideration of the human side. What is it around training? What is it around connection? How do the technology and the human work together? And you've given some really nice examples. And then the fact that there's lots of different kinds of humans from around the world with different abilities, different capabilities, and so on. So really nice highlighting. And I'm going to remind people again that they can put their questions up. But at the moment, the questions are quite general. So I'm going to keep them for the panel session at the end and invite our last speaker, Satoshi Kitazaki, who is from AIST in Japan. And he's been working on remote control for automated vehicles, low-speed automated vehicles. And he's got a presentation about on the human factor side. So thank you, Rosemary, and let's hear from Satoshi.
Thank you, Natasha. Can I have the slide, please? Thank you. So I have been a director of Automotive Human Factors Research Center from 2015 to 2019. Then I established a new research center, which is a Human-Centered Mobility Research Center. So since a year ago, we expanded the research function to include all kinds of, well, basically, ideally, all kinds of mobility as well as automated, as well as the cars. So my experience has been really focusing on human factors in automated driving of passenger vehicles. So this is very new to me. I have experience of only 1 year, but I try to explain a little bit of human factor aspect of the mobility service today. So I'm going to introduce another project. Next one, please. Can I have the next slide, please? Yes, the project was shuttles and bus services, and partners for Ministry of Trade and the Ministry of Land, Infrastructure, Transport and Tourism. And it was a 5-year project from April 2016 to 2020, sorry, March 2020, last year actually. And the total budget was 25 billion euros for 5 years. So this project came to my Human-Centered Mobility Research Center last year. Only the last year, 5 years, came to the research center. The purpose of the project to demonstrate services in rural areas with poor public transportation and evaluate the technology and the services in terms of social acceptance, sustainability of the business models. The scheme was that I received the fund as a supervisor and the advisor and subcontracted to consortiums and local governments for facilitation of services. Yes? Any problem? Yeah. Okay. Okay. So the location of the consortiums, subcontractors in 2020 are 2 locations for shuttle services and 1, 2, 3, 4, 5 locations for bus services. Can I have the next one, please? Yes, so the blue 5 cities in blue are for bus services, and 2 places colored orange are 2 places for shuttle service experiments. And next one, please. And I'm going to focus on the upper orange one for shuttle service. The name of the town is Aichi in Fukui Prefecture. Actually, they conducted experiments for several months, and in December last year, they finished the experiments and they actually started actual service. And the fare was 100 yen for adults and 50 yen for children last year. Next one, please. Next slide, please. Eiheiji is really a small town or village in mountainside, and the red line indicates the service route. Total length is 6 kilometers with traffic with pedestrians and bicycles, but no other cars. And weekdays, crew staff on board in for entire 6 kilometers, and weekends, no crew in the shuttle on board for the last 2 kilometers. Next one, please. Can I have the next slide, please? Yes. This is the vehicle. The blue ones, blue tags indicate sensors for automated driving, and red tags are sensors and cameras for remote telecommunication with the remote control room. And there is a tunnel command as well. Green. Actually, the car basically the car goes with GPS and sorry, the car goes along the electromagnetic induction wires, old technology for the area 6 kilometers, plus yes, and also the car has detection sensors, cameras, lidar, etc. And also remote operation is included. The upper photo is the operation room, and the one monitor, one operator is for 3 vehicles, and there is a operator state monitoring as well to detect the operator going away from the seat and drowsy and looking away from. Can I have the next, please?
Satoshi, sorry, can I interrupt you for a second? We're having problems hearing you. Your camera still seems to be on.
Yeah.
So would you mind just turning your camera off, and hopefully that will make a difference.
Okay.
Right, let's have another go. Okay. Yeah, hopefully this will work better. Thank you.
Okay. Okay. So how they made it? The route and traffic, the 2 kilometers long for no man driving vehicle, and just with electromagnetic induction wires, and mixed traffic with pedestrians and bicyclists, but no other cars, and no intersections. The 2 kilometers long. The vehicle speed is 12 kilometers per hour, so it's very slow. And onboard crew is none, and number of vehicles per remote operator is 3. So 1, 2, 3 operation. Takeovers. When a vehicle detects an object, it stops automatically. Then a staff goes to the vehicle to solve the problem. So staff runs to the vehicle to solve the problem. So that makes it no takeovers of running vehicles. At stops for loading and unloading, the vehicle stops automatically at the stops, but remote operator presses the button, start button, after checking the passengers in seats and the traffic. And weather condition, if the weather is bad and the service it does not start. The next one, please. Next slide, please. Yes, assurance of safety. In case of passenger vehicles, the driver and in-vehicle system interaction is the issue of the discussion, especially for human factors. And in services, first, we have to assure the safety of passengers, not the one driver, but passengers. And safety is issued by in-vehicle system, remote operator, and service design. So very complicated, as Joanne said previously. And service design includes design of ODD, interaction between remote operator and vehicle, and number of vehicles per operator as well. So it's very complicated, and we need a framework. Next one, please. Probably have spent too much time. So this is one insight into human factors in remote operation, how vehicle speed and 1 to N for continuous monitoring can be enabled. Basically, we expect a remote operator scan monitors, in this case, 3 monitors from 1 to 3 for vehicle 1 to 3. But if the operator can set a safety margin for vehicle 1, then the operator can switch attention to the next vehicle and next one as well. And when the attention comes back to the original one, if the vehicle is still within the first safety margin, the vehicle should be safe. So this is just a hypothesis, and we need to validate this hypothesis. But anyway, we need a theory to determine n of 1 to n. Next one, please. Yes, so research questions, technical questions for better services. How can the vehicle speed be increased? And how can n of 1 to n be increased? Stopping for all object events may not be ideal for efficiency of services. So how can the service be steadier and more efficient? We need to consider delay time intercommunication between the remote system and in-vehicle systems. And we need to consider remote HMIs for better attention allocation. And we also need to consider training of remote operators. And most importantly, ODD is very important. We need to define ODD for services. The next one should be the last one. Can I have the next one, please? Yeah, AIST is now a new 5-year project, national project is going to start, and AIST is expecting to achieve the grant to conduct such fundamental research for safety. So keep fingers crossed. Thank you. That's all from me.
Thank you very much, Satoshi. Excellent. Okay, so we will now almost exactly in terms of the time, we're on the panel discussion session. We are having problems, unfortunately, with our speakers being able to connect. Joanne, we've lost you at the moment. I don't know whether you're there or not. But can we have all of the speakers back on, please, so that we can now discuss the questions that are being addressed. And I've just noticed the window cleaner has arrived. So if you see a strange man behind me, you know, this is what it's like working at home. He's just cleaning the window. So as you have noticed, the human factors side of remote and teleoperation is really just kicking off, or understanding what are the human factors, complications and questions that and challenges that we need to address from standardization onwards. There you go, there's the window cleaner. Okay, so we've got some questions. Just 2 or 3 people have asked quite a few questions, and I've got my own questions to kick things off. So I think one of the things that is of interest, and being aware that for some of you, I know that you're only just starting and you are asking the same questions that the audience is asking. But I'm just wondering if you can say a little bit, and I leave it to you to decide who wants to answer this question, regarding whether it's actually the same ideas, the same human factors questions for all types of remote operation, or whether we have different considerations to make depending on the different use cases. Who would like to respond? Oh, Joanne, you're back. I'm very happy to see you. So, Azra, do you want to have a go at that particular question?
Yeah, I can try. Thank you for asking. Well, as you said, we have been dealing with human factors in remote operation for a while in many different domains, but I think there are quite many similarities between automated vehicles and other domains, but there are also some certain differences. For instance, that we have when you are in traffic, the context and the situation itself is usually more complex and complicated as compared, for instance, to some very well-defined industrial areas or factories, for instance. That's one differentiation for sure, but could also be about safety criticality, that in some industries, if you make a mistake, maybe it will not lead to people being killed, while in traffic it could lead to crashes and involve also people who don't have anything to do with automated vehicles, you know, other road users around them, like pedestrians, bicyclists, manually operated vehicles. That's one thing. And also I want to highlight that even within automated vehicles, there might be differences depending on the application area. I showed you 2 examples that we are looking at: heavy automated vehicles and small autonomous pods. And I think these vehicles will be operating in different environments. To put it in technical language, they will have different operational design domains. And I think it will certainly mean different requirements in terms of well, human factors, how you design interfaces and how you deal with human factors. Now I give word to someone else.
Yeah, thank you. Well, I'm going to go straight on to one of the questions that's been there from the beginning regarding training. And I know that Joanne, Azra, etc. mentioned that training needs to be considered. And I'm just wondering, for those of you who are actually got a bit more hands-on experience, so maybe Rosemary, can you say a little bit about the training? Are there already guidelines and documents, etc., regarding what needs to be considered? And a related question around operator situation awareness and really helping the operator in terms of their training and their situation awareness. Is that something that maybe you can let us know more about, Rosemary?
Yes, thank you, Natasha. Well, I would say at Volvo, we are not so mature yet, I'm afraid. But I have visited some other sites with some of our, not competitors, but some other machines where they have gone further and talked to operators. And most of them think that the learning or the training time is very short, actually, 3 or 4 days. But this is very confined areas, of course. And I would say we had some tests yesterday, and there was a guy, he had been running the machines as usual, but never in the Tele station before. And he managed to start to do very tricky operations in just a few minutes. But the most difficult part is that they all feel far too safe. You know, they start to reverse without really looking at the right cameras or the right display. So we always have to remind them. And I think that is, the training is not the tricky part. The tricky part is to really not make them feel too comfortable with this. They have to realize this is still for real. I hope I answered some of your questions in that.
Yeah, absolutely. And I guess, you know, looking at it from the driver side of things with automation, it's just, it sounds like this general aspect of complacency, which comes in. So, you know, feeling that, you know, the sort of automation is looking after things and forgetting, and lack of skill or loss of skills after a while, which I think is something that is happening with respect to drivers. It's interesting that you say that there isn't necessarily that much involvement of training, and certainly, again, maybe it's not that critical when you're looking at your particular use case, Rosemary, but we are trying to discuss what it means with automated vehicles and for vehicles. So it's then becomes a whole new area for discussion. So, I mean, I think there's an interesting question which is related to that around what the remote operator sees. Is it just about the sort of the video and the video feed, or is there any more information? I don't know whether Satoshi or Azra, you have any more information on that you can share with us regarding ideally, what are we expecting the remote operators of these automated vehicles in the future to be able to see in terms of interacting with the stranded automated vehicle, for example?
I can start, and then I hope that Satoshi can give some information from hands-on experience. I just want to add a few words on the previous question on training. And I think it's in many cases, it will be, as Rosemary said, that you don't need that much training. But I'm more worried about these, what we call edge cases, these situations that may happen once a year, or maybe not even that. And then suddenly, as remote operator, you are expected to know how to handle this. So, there are many, as you could hear from our talks, there are many challenges related both to monitoring and assisting vehicles. But I'm really worried about training aspect when it comes to actively controlling or driving vehicles, because it will not happen very often, and remote operators may never have chance to practice in advance on some situations that they will face. So that's one thing. And then related to your question on what they will see, what we have seen from, if you look at literature and what the different stakeholders are anticipating how they have built their remote centers, you can see that they use several screens to display different views from around the vehicle. And I think that could be one of the positive things, actually. As remote operator, you will be able to get a much wider view as compared to being in the vehicle and driving the vehicle from the spot. You will have access to sensor information. As vehicle driver, you don't have, you don't see what our sensors seeing and so on. In the best case, you see some warning messages and so on. But as remote operator, you will have access to much more information. But of course, here we have to make sure that we don't get information overload, and to have clever systems that present relevant information in the right moment for remote operator.
Well put, Azra. I have to agree, spot on there, actually. And that is one of our challenges, that we try to hammer people with all kind of informations, and then when we do the training or when they try out, they don't know where to look, and they can't sort out all the information. And that is very important, the correct information at the correct time.
Yes, I mean, I'm kind of halfway between the two of you regarding training, because I feel that we're effectively looking at a very different set of skills, and as you mentioned, overload, distraction, etc. So while they might not be happening very often, knowing where it's going to happen and how to deal with it and which screen to look at, I don't think that's a menial task in itself. So sort of understanding, what we need, what information is provided to the operator and when, I think is and then how to deal with it, I think is crucial. And I've just spotted a question around latency and lag, and I don't know whether anyone wants to comment on that. Sort of, that I feel is something that maybe technologically speaking, we're not quite there yet. Joanne, is that something that you want to pick up on? Because I know that you've sort of talked about it a little bit in terms of your the HFI rights paper.
Sorry, just unmuted myself.
Okay.
Yes, it is mentioned in the paper, Natasha, that's a really important consideration. And it's interesting to think about what the components of that lag might be. So initially something will happen at the vehicle. It needs to be understood. Somehow that information needs to get to the remote operator. The remote operator needs to synthesize that information to be able to understand what's going on and then affect some sort of thing as well. So there's a lot of moving parts in there. I can speak to that part of it. I can't speak to the technology aspect or the infrastructure that would support that or improve it. But certainly those are concerns. Perhaps someone else who's done the on-road work with the vehicles would have more information for that.
Anyone? Yeah, go ahead.
Can I? Our system, the time lag is about 500 milliseconds. And in our experiment, trained operator can control the vehicle with that delay at very low speed, only after training. So definitely the time delay is an issue for needs of training. And also, as I explained, we expect that one operator monitors multiple vehicles. That is important to reduce the labor cost. And if the one person monitors 3 vehicles, I think that the operator has to be trained to pay attention equally to multiple monitors, and also task switching issue. So for those, training is quite important. And actually, some of you may know, we have been conducting research on importance of education on automated passenger vehicles, and we found that education had a quite large effect of for successful takeovers. But for passenger vehicles, education opportunities are very limited. So that's why we are working with police agency in Japan, but still difficult. But for services, it is much probably easier to establish training opportunities for operators. And also, if we think about aviation, aviation controllers, they are all trained. So why not go for training for automated services? That is an inspiration. But importantly, the cost is a very important issue for deployment of services. And the cost for education must be cheaper than the cost for professional driving license for services. Otherwise, the service will not be sustainable. That's another quite important issue.
Thanks, Satoshi. I've got a bit of a follow-on question regarding the technological side and the availability of 4G versus 5G. So at the moment in Japan, do you have 5G?
In some places.
Okay, so the question.
But those services do not use such high-tech things.
Okay, so there's the sound is coming and going, so I'll hopefully be able to get an answer from you. But it's around sort of whether teleoperation of passenger vehicles need 5G or can they work with 4G? Because obviously in rural areas, at least in the UK, etc., we're not still there with the 5G side of things.
For the telecommunication?
Yeah.
I think that 5G is suitable, but and I'm not sure if they use 5G for telecommunication, but what we are discussing is always the cost. If we set up the expensive remote controlling system, that might be faster, but the small villages cannot afford that. So we have to reduce the cost of the system and we have to really improve the HMI, which can make the operator to control the vehicle with some delay. So we need a very good HMI as well.
Okay, thank you. I have some difficulties. I don't know about everyone else.
Connection.
It's
I can add one. I can add
go
one
ahead.
thing, and that is that we
Sorry.
try out with 4G, and we have not done anything with 5G yet. But
Okay.
4G is satisfying, and also regarding latency, we have done some evaluations together with RISE and Swedish companies regarding latency, and we are still working on it. And we are looking very much how much that the latency affects the operator, not just in the safety matter, but also in the feeling of nauseousness and everything. Maybe Azra was going to say something about it, and I'm sorry if I jumped in.
No,
You
it's okay.
Go,
It's okay.
go ahead, go ahead, Azra. You can go ahead now. But 4G is enough for us. And if it is too slow, the network, the big problem is that the operator can't do it. He feels sick, actually.
Okay.
But you can continue, Azra.
Yeah, I can just add a few words that I think it highly depends on what kind of application and what is the task of remote operator that we are talking about. If you remember, both I and Joanne mentioned these very rough three types of applications or task. One is monitoring and the other one is assistance. And I think for these two, it's not very time critical. And we might be able to accept some delays, given that we can deal with the issue that Rosemary highlighted here, that actually it could cause some motion sickness or whatever you call it for remote operator. But if we talk about actively controlling and driving vehicles, for sure, I'm very doubtful if it will work with 4G, at least not in long run when you have many vehicles, if you have, large fleets to control. In that case, I think we will need 5G as it becomes very time critical.
Okay, that's a really good answer. Thank you so much for that, Azra. Okay, so we just a few more questions here. One around the connection of the remote operator with passengers. So is that something that any of you are aware of, that is also being considered in terms of automated vehicles, automated shuttles? And also a particular question to you, Satoshi, around how many times, if any, have you seen that the remote operator has had to intervene? So anyone got any sort of answers regarding the connection with passengers? Is that happening?
Sure.
So, Joanne, go ahead.
Sure, I can start with that. We have done some shuttle work in Ottawa, and one of the interesting things we found was that when we asked passengers about, do you trust are you comfortable, or do you trust being on a shuttle? The answer really turns out to be, it depends. And so they're quite sensitive to the speed of the vehicle, the operational design domain, and those sorts of things. And in particular, we were interested with whether or not they felt they needed someone on board with them, or would they trust a remote operator? And certainly at higher speeds, they weren't feeling comfortable with that. So that connection there, and having someone that you can access information to really quickly, and it takes the trust, it affects it a lot. But then there are also ways of improving that on board. Say if there is a connection, an obvious interface with an external person, I think things can be improved that way.
Okay, so and are we aware, for example, Satoshi, and by the way, Satoshi, even though I'd love seeing you, we might have to ask you to take your video off just so that we can hear you. Can you say a little bit more about whether there is that connection already in your shuttles with passengers? So there is some communication. Do they see the operator, for example? And can you also give us examples of whether how often that connection has had to be made with the passengers in the trials that you've been involved in?
Inside the shuttle cabin was monitored all the time by the remote operator, but I don't think passenger can see the remote operator. But the consideration is for starting from stops. The shuttle stops automatically at the stop, but when starting, the driver usually has to check if all the passengers are seated in an appropriate position. So the bus doesn't start automatically, but only operator starts the bus after checking all the passengers were seated in appropriate positions. So that was the considerations. And I haven't heard any other remote remote operators interventions for that. But our service has only 2 kilometers long. So if anything happens, just the staff just runs to the bus to solve the problems. That's the first step.
Yes, I've noticed that years ago in the City Mobile 2 trials as well, that's because they're going nice and slowly at the moment. Obviously, they're trials and based on making sure it's all safe. So it's slow enough to be able to just quickly run and help. And but still, the use case, understanding how it's going to work when it's a bit faster and remote, so to speak, is I think still to be studied. And I'm interested in this edge case that you mentioned, Azra, because I'm still not convinced. Well, let us see. But if we're looking at level 4 vehicles where the operator driver becomes incapacitated for whatever reason, yes, ideally heart attacks, etc., are going to be quite rare. But if they fall asleep or they're very distracted, etc., I'm curious to know how little, how many of these what we call edge cases will become actually not just edge cases, but real cases, if you know what I mean. Okay, so let's have a look at some more questions here around. I think we've pretty much answered quite a few of these. So maybe around kind of recognition of standards and also frameworks and licenses, etc. There's a question around some work in the process to build a knowledge framework and sort of remote operated license. Could you give a little bit more information on that? I think again, was that from you, Azra?
Could have been. Well, to start with, I think we need to create a more standardized way of communicating about remote operation. We could already see in our presentation today that we are all using a bit different language to explain more or less same thing. I don't know if they are same, that's the thing. So I think that would be really great to have some kind of agreement or framework. What is what are we talking about? And then also I know that remote operation is mentioned in this SIE standard on autonomous or automated driving systems, as they call it. And I don't know how to put it, but I think that remote operation should take a bit more space in that, given that many stakeholders, or more or less all stakeholders today, they in one or another way assume there will be some kind of remote operation, remote guidance, or call it whatever you want to call it. So I think there should be some more standardized way and incorporated along with these SIE levels of automation, what is the role of remote operation and what are frameworks around it.
Yeah, so the SAE, for example, Day 3016 has done a good job on starting to talk about that in terms of levels of automation for the driver. So that sort of consideration, I guess, and within ISO, and hopefully the HFRS paper will be taken up by the UNECE, and we can see where that goes. Okay, so we've got...
Can I add one more thing, Natasha, there, that I didn't say? And I think it's connected remote operation to policies and regulations that we have is also extremely important. What is the responsibility of remote operator from a regulatory perspective, but also to look at ethical aspects? What if you kill someone as a remote operator? I mean, hopefully it will not happen, but hopefully it's not enough. We need to have to be sure it doesn't happen, and to have frameworks to deal with that if it happens.
Absolutely, thank you for that. Actually, you went one step ahead, because I was going to ask everyone to say one thing that they want to be considered in what is left sort of the 4 minutes. And absolutely, this morning there was a really nice session on the ethical side of things for drivers and automated vehicles. And we're only just starting really to talk about that. So maybe by this time next year, there'll be a session from the Commission side of things, a report on the ethics of remote operation. So 3 minutes left now, and I really want to get the audience back in. We've got that Slido question that we had at the start. Again, I want to know how you feel now, having had some of the discussions about the use of remote operation for automated vehicles, remembering that, for example, at level 4 or even level 3, we are talking about the minimum risk maneuver, and you know, the fact that maybe the driver is incapacitated and cannot take control. So if we can have the Slido questions back on again, and let's see, what do you think? Do you think teleoperation can accelerate the deployment of automated vehicles, and are there a way of making sure that the vehicles are safe to be on our roads? So if you can show us the results, please, while people are voting. I think we can still see those coming in. If you can present what the vote is like right now. So I don't quite see the results on my screen at the moment, if you don't mind sharing. And while that's happening, I just want to spend the last couple of minutes, maybe just say one sentence or one word. What is the key aspect that you would like to be considered when looking at human factors and teleoperation for automated vehicles? So Azra, you've already answered. Thank you. Joanne?
Sure. I think what I'll do is I'll try and pack up 3 things into one thing. I think to echo what Azra was saying, it's really important that we do have some organizational scheme or framework to talk about this. There's such disparate ideas that we're lumping under one thing. And I think once we do that, then we can start asking some of those questions about how could we make this safe and efficient and effective, and answer questions like, are there situations where it would not be appropriate? What are the limitations? And I think we need to think about those as well.
Thank you, Joanne. Speeding up to Rosemary.
Yeah, I would just agree to everyone, and I go back to what I said: collaboration, communication, and standardize. I think that is the key to everything. We are not competitors anymore. We have to do this together.
Excellent, thank you. And Satoshi.
Today's discussion was really valuable to me, and for me, the most important thing right now is to international collaboration, to exchange findings and strategies and things like that. That will be very helpful for us too.
Excellent. Okay, and thank you very much. We've run out of time. We still have over 80% of people saying they do think remote operation is important. So work for us all to do. Thank you very much to the speakers. I really enjoyed it. Hopefully the audience did as well. Thank you very much, and bye-bye.
Thank you.